Rockets are the backbone of modern space exploration and even national defense. But have you ever stopped to wonder, how does a multi-ton metal machine actually fly into space and defy gravity? It seems almost impossible. Well, today, we're going on an exclusive journey to uncover the secrets behind building a modern rocket, from the first sketch to the final fiery launch. Let's dive in. It all starts not in a factory, but on a computer. Engineers use sophisticated CAD software to design every single part of the rocket. Then they run countless simulations. They test everything: how air will flow over the rocket's body, how it will handle extreme heat, the immense force of the thrust, and whether the structure can withstand the incredible stress of launch. The key is to find the perfect balance between lightweight materials and aerodynamic shape, and packing in as much fuel as possible. Before building the real thing, they often 3D print scale models to test their designs in wind tunnels. Once the design is locked, the factory floor comes to life. The rocket's skin, or fuselage, is built from advanced materials like special aluminum alloys, titanium, or lightweight carbon composites. These huge metal sheets are carefully bent and welded together. This isn't just any welding. It has to be perfect. Even a microscopic flaw could be catastrophic. That's why robots and automation are used for precision and consistency. After assembly, every single seam is inspected using non-destructive methods like ultrasonic scans and X-rays, just like a medical checkup, to ensure there are absolutely no hidden weaknesses. Now for the heart of the rocket, the engine. There are two main types. Solid propellant engines are simpler, like a giant firework, while liquid propellant engines are more complex but offer more control. Building one involves creating a super strong combustion chamber where the fuel burns, powerful pumps that feed fuel at incredible speeds, and a precisely shaped nozzle to direct the explosive thrust. Before an engine is ever attached to a rocket, it undergoes a static fire test. It's chained to the ground and fired up at full power. This lets engineers measure its actual thrust and make sure it runs smoothly and stably. It's a loud, fiery, and absolutely crucial step. With the body and engine ready, it's time to give the rocket its brain. This is the guidance and control system. It's a complex network of gyroscopes and sensors that tell the rocket which way is up, and a powerful flight computer that makes tiny adjustments every millisecond to keep it on course. Miles of wiring are carefully installed to connect everything. The flight software is tested over and over in simulations, running through every possible scenario to make sure the rocket can handle anything. The entire rocket then goes through a gauntlet of torture tests, shaking it violently, exposing it to extreme temperatures and pressurizing it to simulate the harsh conditions of space. Finally, we're at the launch pad. The massive rocket stages are carefully stacked on top of each other, creating the towering vehicle we all recognize. The final pre-launch phase is all about fueling. Thousands of gallons of supercooled liquid propellants are pumped into the tanks. All systems are connected to ground control for final checks.
We're running out of time.
Then the iconic countdown
Initiating
begins.
emergency protocol now.
10, 9, 8, all the way to 0, and we have liftoff. It's an incredible moment where years of design, engineering, and manufacturing all come together in a fiery spectacle. So from a simple idea on a computer to a thunderous launch into the cosmos, building a rocket is a true masterpiece of human collaboration. It's a dance between brilliant engineering, advanced material science, and cutting-edge automation. And the story doesn't end here. The next frontier is making rockets fully reusable, which is set to completely change our access to space. Thanks for watching. If you found this journey as amazing as I did, make sure to hit that like button and subscribe for more deep dives into incredible technology. See you next time. Rockets are the backbone of modern space exploration and a cornerstone of national defense. But have you ever wondered how a multi-ton metal machine towering hundreds of feet tall actually manages to defy gravity and fly into space? Today, we're going on an incredible journey to uncover the secrets behind building a modern rocket, from the initial spark of an idea all the way to liftoff. It all begins in the digital world. Engineers use sophisticated computer-aided design, or KD software, to create a detailed 3D model of the rocket. Every single component, down to the last bolt, is meticulously planned. Then, using powerful simulation tools, they put this virtual rocket through its paces. They test its aerodynamics, how it will handle extreme heat, the immense thrust from the engines, and the incredible structural stresses it will endure. The goal is to perfect the design by optimizing key factors like the materials used, the rocket's overall shape, and the crucial fuel mass fraction, that's the ratio of fuel to the rocket's total weight. Sometimes they even 3D print scale models for wind tunnel testing, ensuring the design is sound before a single piece of metal is cut. Once the design is locked in, the factory floor comes alive. The rocket's body, or skin, is fabricated from advanced materials like high-strength aluminum alloys, lightweight titanium, or cutting-edge carbon composites. These massive metal sheets are precisely cut, curved, and joined together. Welding is a critical step, often performed by highly skilled technicians or advanced robots to ensure every seam is perfect. These welds must be incredibly strong and completely pressure-tight. To verify this, the structure undergoes rigorous tests. Automation plays a huge role here, with robots handling repetitive and heavy tasks, increasing both speed and precision. But human oversight is still key. Teams use non-destructive inspection methods, like ultrasonic testing and X-rays, to peer inside the metal and find any hidden flaws, ensuring the rocket's structural integrity. Now, let's talk about the heart of the rocket, the engine. There are two main types. Solid propellant engines are simpler, containing a solid block of fuel and oxidizer mixed together. Liquid propellant engines, on the other hand, are more complex but offer greater control. They have separate tanks for fuel and oxidizer, which are fed into the combustion chamber by powerful turbopumps. Building these engines involves incredible precision engineering to create components like the combustion chamber, the intricate fuel pumps, and the bell-shaped nozzle that directs the fiery exhaust. Before an engine is ever attached to a rocket, it goes through a static fire test. It's securely bolted to a massive test stand and ignited, allowing engineers to measure its thrust and ensure it runs smoothly and stably. It's a fiery, thundering spectacle that proves the engine is ready for flight. With the body and engine ready, it's time to give the rocket its brain. This is the guidance, navigation, and control system. It includes incredibly sensitive gyroscopes and accelerometers to sense the rocket's orientation and movement, all connected to a powerful flight computer. Technicians meticulously install miles of wiring, connecting all the electronic components. The flight software, which contains the rocket's flight plan and automatic control logic, is loaded and tested. They run countless simulations, essentially flying the rocket hundreds of times in a virtual environment to make sure the software can handle any potential issue. The entire system then undergoes brutal qualification tests. It's shaken violently on vibration tables, subjected to extreme temperatures, and placed in vacuum chambers to prove it can survive the harsh environment of launch in space. Final ground-based tests simulate the entire launch sequence before the rocket is cleared for its journey to the launch pad. The final chapter unfolds at the launch site. The massive rocket stages, transported by specialized carriers, are carefully lifted and stacked together on the launch pad, creating the towering vehicle we see before launch. In the final hours, the rocket is filled with thousands of gallons of super-chilled liquid propellants. It's connected to ground systems for final checks, power, and communications. As the countdown clock ticks down, every system is monitored. 10, 9, 8. At 0, the engines roar to life, the hold-down clamps release, and with a thunderous roar, the rocket climbs into the sky. From a simple drawing on a computer to a machine soaring towards the stars, building a rocket is a monumental feat of engineering, material science, and automation. It's a symphony of thousands of people and processes working in perfect harmony. But what's next? The industry is now focused on reusable rockets, a game changer that's slashing the cost of space access. We'll explore that in a future video. Thanks for watching, and don't forget to like and subscribe for more deep dives into amazing technology.